I'm also the Chief Executive Officer for a company called Opt-in, which makes open source peer-to-peer cloud software. I gave a talk about that yesterday. It's been recorded so you can watch it whenever you want. Other than that, who am I? I've been in the computer industry for 1/2 century as of next year. I started programming in 1969. I programmed on almost every size computer in the world, from mainframes to microcomputers to picocomputers. I've worked for very large companies and very small companies. I know what it's like to develop software for somebody else, and I know what it's like to be a customer waiting for that bug fix or that piece of documentation that would help you do your job. I've been a wide variety of different jobs: programmer, systems administrator, university educator, and now CEO. But I am most of all a business person. For those of you who call open source some type of socialistic or communistic thing, you don't know what you're talking about. It is pure capitalism through and through. But it's capitalism with a twist. Capitalism where a lot of times the users are the owners of the software. And I believe in that very strongly. And like Linus Torvalds, I am pragmatic. It means I like to get the job done. It's nice if you have a pure system, but if we were waiting for that, Windows NT would have won. As far as Linux goes, I met Linus Torvalds in 1994 and saw Linux as more than just a hacker toy, more than just a hobbyist thing. I saw it as having commercial value in the world. And so I got my company, Digital Equipment Corporation, to give Linus a $30,000 system so he could port Linux to a 64-bit processor and get out the Intel-isms so that the Linux kernel could be portable. I assembled a DEC engineering team to help him. We didn't have very much help because the community did the bulk of the work. And in 9 months, that system was ported. It was amazing. In 1995, I joined the Linux International Group, and we helped to do certain things that made Linux easier for businesses to have. We helped defend the Linux trademark when somebody tried to steal it away. We created the Linux Professional Institute for certification of Linux professionals. And we created something called the Linux Standard Base, which helps to make Linux upward compatible all the time. And since that time, I'm promoting Linux and free software in general and open source worldwide. I make my living as a consultant, and as of July of 2016, I became the chairman of the board for the Linux Professional Institute. I'm going to introduce you to just a few people here. In particular, the young black man down in the bottom with the hat on. I met him in Soweto, South Africa. Soweto was a very, very poor city. It was a place that before apartheid, they provided the service for the people living in Johannesburg. And after apartheid happened, Soweto started to turn around, but it was a city of 500,000 people, and it turned very slowly. I went to Soweto, and I looked out over the city, and I said, I think there's even free software here in Soweto. And the man from the government who was with me said, oh no, you're wrong. The people in Soweto barely know what a computer is. There couldn't be anybody working with free software here. So I went back to the United States, and my friend went to his boss in the government agency he worked for and said what I told him what I had said. And his boss said, let's go see. And they started a conference much like this in Soweto, and 350 people showed up to find out more about free software. In the front row, there were these 3 black people talking to each other, 3 young men. And after the conference, the government officials went up there and said, what are you guys arguing about? And one of the black men pointed to this gentleman and said he runs a consulting company out of his house with dial-up networking because the government won't help us get internet. And he's helping Linus Torvalds debug a problem in the kernel with the AMD memory subsystem. This gentleman had never been to college. He had simply learned on his own with dial-up 19.6 networking. And the government officials were so impressed that by the next year when I went back again, they had opened up an open source development center in Soweto, South Africa. Many, not all, but many of the people on this slide have done amazing things and had not gone to college. As a matter of fact, that young man in the right-hand side in the middle never really graduated from high school. By the time he was 15, he had finished all of the courses he could take at his high school, but he was too young to graduate. He never went to college. Instead, he became the systems administrator for a university, and he trapped some people trying to break into the university system by setting up a honeypot. The FBI of the United States went over to Italy and found them and put them in jail. And he ended up in Forbes magazine with a 2-page spread about the things he had done. He never finished high school. He was doing graduate work eventually in optical devices for the next movie of Star Wars, the next generation of Star Wars movies. And this is actually my latest hero, a person by the name of Marcello Ballesteri. He probably would be embarrassed if he knew I was showing this slide. But I met him in a favela in Rio de Janeiro. He had taken some computers out of the garbage at the bank where he worked and asked if he could take them home. And he took them home, he reconfigured them. He installed Linux on it. He found some books in the trash. He taught himself how to do systems administration. He started an ISP inside the favela, and people laughed at him. They said, "Nobody will ever pay you for internet service." He ended up employing 6 people full-time, selling internet services inside of the favela, because people realized that now they could get the information about themselves out to the public and bring in people that would buy things. He sold off that company and started a small one-room school with a government grant. That's when I met him. And he told me, "Maddog, they used to talk about guns and drugs, and now they talk about the internet and hosting." He left that, and now he's working for the university, the Catholic University in Rio de Janeiro, in systems administration and IoT. And we'll come back more to that later. Now, a lot of times I talk with university students, and I say, "What do you think the goal of a university is? To get you a job?" And they go, "Yeah, get me a job. Train me for a job." No, you're wrong. Because a university's job is to teach you how to think. It's to teach you how to take data and turn it into information. It's to teach you how to be critical thinkers to make you a good employee in the future and a good citizen of your country. To create a thinking electorate. That's what the job of a university is. When you go on for your master's degree, the job is to help you figure out how to solve a problem that nobody else has ever solved before. And a PhD is a culmination of that. But none of those things are about teaching you how to do a job. Because if that was the only thing it was teaching you, how to use tools to do a job, then every few years you'd have to go back to university to be trained again as the tools changed and the job changed. Universities also do research. They want to find out new things. And they want to be able to take that research and turn that into new products with advanced development. So you have pure research, you have directed research, which is often funded by private companies. You have advanced development that takes that pure research and turns that into something that might become a product. Then you have product development, which is what most people think of as engineering. And then you have sustaining engineering, something that takes that product and continues to make it useful throughout its entire life. So all of these things are actually about teaching thought processes. They're not about teaching a specific product. And any university that goes in and says, I'm going to teach Cisco networking instead of networking in general, or I'm going to teach Microsoft Office instead of how to use your Office product to make your business better, or Oracle database instead of data structures and database theory and design, or Nortel Communications. Oh yes, Nortel Communications. Certifications in Nortel. How many of you remember who Nortel is? Oh my God, that fast. Nortel at one time was the second largest telecommunications company in the world. And in 2 years, they went from that to bankrupt. So all of the people who got Nortel certification, it's gone. Forget it. Your job or your training is worthless. Now, if you'd learned how networking worked in general, you could have reapplied that to another telecommunications type of protocol, and you would still have a job. That's why when people say to me, oh, Maddog, we're learning the world's largest software company, what their products are. I say, oh, really? The largest? Oh, yes, because they'll never go out of business. Like Digital Equipment Corporation, or Compaq, or Enron, or Nortel, or Kodak. I could go on and on and on. Now, a lot of people say you can't make money with open source. When that first slide I showed you, I had at least 3 multi-millionaires. And they all made their money with open source. I had a person come up to me just this year and said, Maddog, I listened to you 20 years ago, and I went with open source. And I just sold off my part of the company, and I sold it for $2 billion. Can't make money with free software. Okay. But you can make money with free software all the ways that you make money with proprietary software. You can, unless your name is Bill Gates, this is what you could do with Microsoft software. You can install it. You can teach people how to use it. You can be a systems administrator for it. You can integrate with it. You know, all those things. And you can do all of that and charge for it with free software. And with free software, you can do one more thing that unless your name is Bill Gates, you can't do with closed source software, and that you can change it to make it meet the needs of the customer. And that is a high value item. And you can do it locally. Here in Brazil, you don't have to go to Redmond, Washington, or Silicon Valley. You can do it here in Brazil. And when you keep that money in Brazil, it means that that money can circulate inside of Brazil. The money that's paid to you as a programmer, you'll buy local food, local housing, and pay local taxes. And then those people will then come around and say, gee, we need to have some programming done. Will you do it for us? But once you send that money to Redmond, Washington, there's only so much cachaça that Bill Gates is going to drink. Ballmer used to drink a lot more cachaça, but believe me, not even Ballmer could drink that much. And here's another thing, another surprise. People do not buy hardware or software. There are very few people in the world who have a box of Oracle software glued to the wall with a candle on either side like a shrine. Maybe Larry Ellison does, He's the CEO of Oracle. There's very few people that have a piece of hardware glued to the wall. Maybe Steve Wozniak does. It's the Apple I. He deserves to have it. But people do not buy hardware and software. What they actually buy is a solution. And you should be able to create that solution as well or even better using free software than you can with closed source proprietary software. And then because you do not have to pay the license fee for the proprietary software, because the free software is free, that means you can stuff more profit into your pocket for that solution than your competitor. Or you could undersell your competitor and still have the same profit in your pocket. And that's where free software really wins, because it develops a better solution for the customer. Now, while we're talking about costs, let's talk about free software. I come to Brazil and I talk about free software, and some people say, oh, Maddog, all of our software is free. That's because you pirate about 84% of the desktop software. And people will snicker about that, particularly young people. Yeah, we do. Yeah, we sniffer. But remember, when you start developing software and you want to sell it, you don't want people cheating you. That's when they stop smiling. Nothing is free. There's the cost of electricity, the cost of servers, the cost of hardware, the cost of materials, the cost of transportation. This is why people have to charge for their work, and even with free software. But you can make an advantage to that. And even a mother's love is not free. If you love me, you'll take out the garbage. If you love me, you'll feed the pets, right? Yeah. Even the water we drink is not free. It has to be treated with chlorine and stuff like that. So here are the 4 functions that I think of an educational body. What do they do? Why do they do it? They help to set a path for you to learn the information. What do you need to know first so you can learn the other things second and third? They need to teach to those objectives. Those are the path of the objectives you need. They need to teach to those objectives. And then they have to certify that you actually learned it. And these are the tests or the programs you do, the examples you create. This is what an educational body does. And finally, they research new objectives. How is this changing? What do we need to do that's new? What do we need to teach that's new that we didn't teach last year? For example, Internet of Things. Now, there are many paths to get this education. The traditional path is going to university or some type of college or maybe a professional teaching organization. But you could also do cooperative education, which means that you work part-time and you go to school part-time. That's very good because that forces you to go into a real production environment while you're learning. I almost became an electrical engineer. That was back in 1969. But as part of my cooperative education meant I had to work in a real electrical engineering facility. And I was almost electrocuted by 13,600 volts at 800 amps. Let me tell you, if that ever happens to you, it wakes you up. I immediately went into software. The worst I could get was a paper cut. A guild program, used for hundreds of years in England. You start off as a novice, as an apprentice. You're apprenticed to a master craftsman. They teach you what they know. And then after a while, you go out as a journeyman, practicing your craft and learning more as you go along. Finally, you yourself become a master craftsman, and the guild tests you to see if you know. In Great Britain, they're actually forming a guild for systems administrators to take people and put them on a fast path to doing this. Mentorship, finding somebody who knows a lot about the subject and they help you learn on this path. I have a young friend who was introduced to Linux by his uncle. And he was using Microsoft systems and playing games and stuff. His uncle said, no, you really need to learn Linux. And on July the 28th, he will be graduating from the Catholic University of Rio de Janeiro as a computer engineer. Self-learning, looking at the internet, reading books. This is another thing that a university teaches you, is how to find the information and how to decide whether the information is relevant or not. And today, there's a lot of online courses from Rice University, Stanford University, that you don't even have to sign up for the course to get the knowledge. All you have to do is search the internet and take the course material. Now, so far I've been talking about free software in general, but there's another part of it which is called free culture. And it goes beyond just free software. It talks about open standards, free and open standards, standards that are developed by people like you working together in an open field to be able to help determine where the software is going to go, or the hardware, or the culture is going to go in the future. And this enables interoperability and longevity in the products, because it's not just done for some specific tiny little function, but typically the broader function. And so free and open source software reduces the costs of producing the software, allows you to come to market in a timely way, and allows you to work with other people in doing this. Now, other examples of free culture, Creative Commons, which allows you to share your digital type of art and music and photographs. You can actually build a business out of sharing your information. You may create a Creative Commons license for people who just want to have the picture and put it up on the wall. That's very free. But if you want to use it for commercial use, if you want to make a commercial out of it, if you want to resell it, that's a different license, and maybe you need to pay. But by using that license, you expose your art to many, many more people who might look at it and say, yeah, I want to do the commercial license. Open hardware is allowing people to work together to create new projects and new hardware. And we'll see a little bit more of this later on. Now, there are some distributions of Linux, in particular Debian, that have a focus on education, and particularly kindergarten through 12th grade, or what we call elementary school. In this particular case, Debian Edu School Linux is probably one of the best ones at this point. Now, should everybody learn to program? I'm asked this all the time. Should everybody learn to program? I think that everybody should learn to write some type of simple program, just to understand the complexity of it, just to understand that computers don't think for you, just to understand that if they ask you to do something, is it something that's going to take forever, or is it something you could do in 10 minutes as a programmer? If you write even the simplest program, you begin to understand that the machine is incredibly stupid, and that maybe what you're asking is incredibly hard. Then some people say to me, well, if everybody should learn to program, what language should they use first? And I recommend that if you're a young person in high school, or elementary school, maybe elementary school, use something like Scratch or Turtle Logo or something like that that's fun. It helps you create a little program, but it also shows you the complexity of decision making and repetition and telling the computer what to do. After that, I recommend, particularly if you're using Unix and Linux, that Bash is the next language you should learn. because it's always there. It's always installed. It's very powerful, and it gives you the sense of variables and if statements and decision making. After that, I would typically talk about Python. I like Python as a language. Some people might say Perl, PHP, other types of scripting languages, but I think that Python is very portable and it is a very powerful language. And then I say something unusual. I say you should learn assembler, some assembly language. I don't care which one. The simpler, the better. If you can find a PDP-8 emulator, please learn that. Because that will teach you what referencing memory is like, what using a register is like, what dereferencing a null pointer is. And after you learn that, you'll never forget it. And after that, you can learn a language like C or C++ or Objective-C. And all the people who complain about C and say what a terrible, crappy language it is, I will point out that every kernel in the world is programmed in C. So it can't be that bad. If somebody can show me the kernel of an operating system is programmed in Java, or even a database engine, please, Larry, you own Java. Larry Ellison, show me that you've rewritten the Oracle database in Java. Right. I don't care if you learn Java, fine. There's a big market out there. But learn something else. Learn how the computer really works. So, on the internet, there is a document called the IEEE ACM Computer Science Undergraduate Curriculum Guidelines. It is a hugely thick document. It tells you all the way through the courses you should take, like math courses and things like that, and then computer science courses that would lead to an undergraduate degree. It tells you objectives of the course. It tells you the prerequisites for the course. It tells you the suggested textbooks to use for the course. And this was a document that has been argued over and discussed and agreed to over time. They do it typically every 5 years. And this is, I think, the 4th or 5th edition of this. And they do not specify what operating system or what programs you should learn. They let that up to the professor, up to the teacher of it. But I'm going to make some suggestions. If you're teaching operating systems design, for instance, you have a wide variety of different kernels you can show people. Not just Linux, but you can start them off with FreeDOS. Very simple operating system, very small. You can look to see how it works. And if you compile it, it actually runs DOS programs from the early days. But it's a relatively simple operating system for a simple time. It allows you to see how interrupts work and things like that. After that, you can look at Linux and see, but Linux is a huge kernel, sometimes hard to understand. You could also look at the BSD kernels, which are a fine implementation of a kernel of an operating system. FreeBSD, NetBSD, OpenBSD. There's an operating system called TinyOS, which is very, very small, and you can take a look at that. It was developed at Stanford University. You can take a look at the CMU Mach, the microkernel, or the Herd, which is the kernel, the microkernel that's being worked on by the Free Software Foundation. Or you could even look at Minix by Andy Tannenbaum. All of these are open source kernels that you can look at and show your students how they work. And they can compile them and make them work. And these are not tiny, crappy toy operating systems. Well, maybe Minix. No, I'm sorry, Andy. But they are multitasking, multi-user, multi-threaded, multi-architecture, and they're used by companies around the world. the largest companies around the world. And therefore, if you learn something about them, you can actually go out and get a job doing something with the kernel. Also, any type of file system you want to look at, FAT16, FAT32, VFAT, NTSC, all these different file systems. What are the advantages of each one, and how are they implemented? You can look at networking file systems. You can look at almost any type of networking I've ever heard of, including DECnet, a networking protocol that was done by Digital. There's actually a free implementation of DECnet. If you're interested in security, there's 3 different security models you can look at. Kerberos, which is a network security model, SE Linux, the security enhanced Linux, and AppArmor. They all have different types of security aspects to them. If you're interested in graphics, you have the X Windows system, you have OpenGL. The person who just left the room was Marcelo Zufo. Last year I went to Marcelo and I said, I really hate it that all these video drivers are closed. For embedded systems work, you could actually make a GPU out of an FPGA. He looked at me strangely and said, "You're right." Then 3 months later, his students had actually made a GPU out of an open FPGA that could pass all of the OpenGL test suites. This is what open source can allow you to do. If you're interested in the high performance computing or high availability computing, we support those too. If you're interested in virtualization, there's 2 virtualization models, Zen and KVM. And of course, there's lightweight Linux containers, another type of virtualization. You have emulators like Wine and QEMU. You have cloud software, Nextcloud, OpenCloud, Apache Web Server, and my product, Subotai, an open source peer-to-peer cloud software. It's open source. You can see how we did it. It's okay. But FOSS is not just the operating system. Every language I've ever heard of has a FOSS implementation, including Ada, that the only existing Ada implementation is called NAT, a free software implementation. We have all the interpreters used on the web. We have database engines and data structures. In case you don't need an entire database engine, maybe you could just use a library which allows you to have linked lists or things like that. Multimedia tools for recording, editing, and so forth. Statistical tools such as R, probably the most used statistical analysis tool in the world. And voice over IP, Asterisk, and other voice over IP implementations. In fact, if you go to a combination of different sites, SourceForge was the original one, GitHub or GitLab, you find out that there's over 430,000 different projects worked on by 3.4 million different developers. And people say to me, "Oh, Maddog, those people don't do programming full time. Some of them are amateurs and stuff like that." Well, there were 70,000 people that work for Microsoft. You know that because it says that in their papers. Out of the 70,000 people, probably a lot of them are managers or sales and marketing people who have no useful purpose. And some of them are people who put software into boxes, and some people take software out of boxes, and some people paint lines on the road in the parking lot, and some people are security guards. And when you get right down to it, there's probably only 6,000 people who have the job software engineer. And some of those people go on vacation, and some of those people sit in meetings. You compare that to the 3.4 million people who do free software. And that's without China and India being fully on board. And as they come on board, there'll be more and more and more people working on free software. And what types of programs are there? everything under the sun. You start looking for them, you surely will find something that will do almost what you want. And maybe you don't use the entire program. Maybe you just use some of it. That's okay, as long as you abide by the licenses of the software. Because now you can build on top of other people's software to come up with a solution that the companies need, that your customers need. And so why do I show you all of this stuff? It's because I've been working on a little project, basically building a high-performance computing system in a briefcase. I started this about 5 years ago when the Raspberry Pi came out, and then another little computer called the Banana Pi and the Banana Pro. And I took about 6 Banana Pros and put them together with a networking switch and 2 terabyte, 2.5-inch disk drives to create this thing, which I could use to teach things to students. I could teach high-performance computing, so they could program it just like a Beowulf supercomputer. I could teach high-availability computing by unplugging one of the systems, and the students could watch it do failover and be able to keep on going. I could teach heterogeneous computing, where you're running different operating systems on it, and they're all interacting with each other. I could put this system together in a matter of minutes, taking it out of the briefcase. And the prototype cost, which was expensive because I just kept throwing away things, cost about $500 US. But if I was to make it in a less expensive form, it would be $400 US, except here in Brazil. Because here in Brazil, you have 100% import tax on every single one of those freaking computers, and so it would cost you anywhere between $800 and $1,000 US if you were lucky. And that was just too expensive. And so I started a project with Professor Zufo, who left, called Caninos Loucos. It's a project to create little single-board computers here in Brazil, designed and manufactured here in Brazil, mostly from Brazilian products. And I've been talking about this for several years because the original idea was to simply make a Raspberry Pi-like system available here in Brazil. And it took longer than we thought, but it was better than we thought, because now it consists of 3 different computers. A little sensor computer, which we call the Pulga, or flea. And the Pulga has about 20 different sensors on it: temperature, humidity, accelerometer, a microphone, things like that. It has an ARM M4 processor, and it talks Bluetooth mesh or LoRaWAN. It runs off of a battery for about 6 months. 2 batteries can put together for a year. And it might communicate with what we call a Labrador. That is the Raspberry Pi replacement, manufactured here in Brazil by Brazilians of mostly Brazilian parts. But we wanted something more than that. We wanted something with a little more oomph, a little more capability. And so my company, Optin, contributed a design on GitHub for a router system that is also an Internet of Things gateway, and it is also a NAS system, network attached storage, and it also mines cryptocurrency with only 18 watts of electrical power. It can run off a solar panel and therefore eliminate the issue that people are talking about, that cryptocurrency is somehow going to burn up the universe with mining of cryptocurrency. And all of these are being produced at the University of Sao Paulo in Brazil. At the end of this month, we will have engineering prototypes to port the software to, and by the end of August, we should be in mass manufacture where we can produce over 10,000 a day. The little fleas, we can produce 250,000 of these each day. And if we need to produce more of them, there's 150 companies in Brazil who have surface mount technology machines that will help us produce them. That's why this is interesting to me. Because I would like to see computer education for all. And therefore I went on to take some of these computers and build what I call a computer education in a box. Because if you take a 64-bit computer that has a great deal of capabilities and a 32-bit computer, which is very strong in its own right, if you put both of those in a box, you can then do cross-building using the 64-bit computer as your server and the 32-bit computer as your target. Then by adding a disk drive to the 32-bit computer, you can turn it around and have the 32-bit computer be your server system, your development system, and doing development for the 64-bit system. You can put all of the training materials which you need onto 2 USB flash sticks, one for 64-bit and one for 32. And you can ship the entire box out because these systems will act as a server for the development. You only have to provide the updates over the internet. So if you're teaching in a place that the internet is very poor, you only have to bring a small number of bytes over to update the materials before the students can use them. You can put these materials into a plastic box along with everything else the students need, maybe a little circuit board design system. You can also add additional breakout boards and things like that, which are available off the internet or from somebody like Flippy Flop. All the cables and all the materials necessary are in the box. And it could be that you could simply reuse the box over and over again. If somebody gets finished with the box, they send it back to you. You check to make sure everything is okay. If everything was returned and okay, you give them their deposit back. These could also be subsidized by government, industry, and local benevolent groups. But the cost of this would be very, very small. Currently, I'm working with China and some groups in Brazil to take this forward. But we could also do this in Argentina and Uruguay and other Latin American countries. Because there's many, many little boards like this that are kind of interesting in one way or the other. It just takes some people to work it into a curriculum. So this is all more than just free software. It's open standards, it's open certification. LPI has been in business since 1999, certifying Linux professionals. For a small amount of money, you can take a test to prove that you really know what you know. And those with letters of recommendation can help you get a better job. We do it in an open way. And we now have 150,000 people in 180 countries around the world who have taken our certifications. Now, I went to Burlington University in England, and they were teaching all sorts of network and systems administration. I asked them if they had Asterisk there. They said, yes, we do have Asterisk, but we're not teaching it yet because none of the professors know Asterisk. I said, you're teaching so 1980s. What you do is you take your brightest students and you give them the challenge of learning it, and then they teach the class. And the professors went, oh my God, that's brilliant. Because the best way of learning something is to teach it to somebody else. If you're sitting there trying to learn something as a student, you say, okay, I don't quite understand that, but you know something? The professor probably won't ask that on the test. And maybe you'll get away with it. But when you're teaching it, you have to know everything, because you know that your student is going to ask you that question. I know, because I flunked compiler theory the first time, barely passed it the second time, but then when I had to teach it, I learned it well. And now, even though it's been 30 years since I've last formally taught a class of compiler theory, I could go up to a whiteboard and I could teach it cold. The best way of learning is to teach other people. And like I said, the Linux Professional Institute is there with a series of certifications for administrators, DevOps, and we're working on a certification for IoT and embedded system programming. And if you get that certification, you can take that with the portfolio of programs you've worked on in the past to a prospective employer, along with letters of recommendation, emails you sent, and show them what you can do. A few years back in Sao Paulo, the FBI, the Brazilian FBI, had a problem. They would have people breaking into banks, breaking into systems. They would go to the house to arrest the person, knock at the door. Is Gerald here? And the little 8-year-old who answers the door says, I'm Gerald. How do you take away an 8-year-old kid in handcuffs? And the FBI went to my friends at 4Linux and they said, what's going on here? What's happening? The 4Linux people didn't understand it. They came to me. I said, script kiddies. These kids don't understand what they're doing. They're just going out onto the web. They're finding people who are breaking in. They're borrowing the scripts and they apply it to 10,000 systems and they break in. And then they brag about it to their friends. And their friends rat on them. And 4Linux created a program called Hacker Team, where they took these at-risk kids and instead of putting them in jail or reform school, they taught them how to be good systems administrators, how to do good security. And today, some of these kids are now leaders in the IT community. Business courses also need updating. We need to teach business managers about free software, what good it does, why you should upstream code, what license you should be using, how do you make money. I know a lot of engineers who come to me begging me for that type of training and that type of certification because it's so hard for them to tell their managers what they don't know. And so the Linux Professional Institute is developing a managerial course, a managerial certification. We call it BOSS, B-O-S-S. Basic Operations of Free Software, or some basic open source software is the name of the certification. We're developing that. And we're also developing concepts around cyber ethics, about why things are bad. Now I'm going to come to the Brazilian IoT program. The Brazilian government has an IoT program. They're investing a huge amount of money into it. They believe that 1% of the Brazilian population needs to know how to program IoT. You can do the math. That's 2 million people. And even if it's only 1 million people, that's still a lot of people to train. And so the University of Sao Paulo has created a course called codeiot.org.br. 50,000 people have already taken it. The course is free. It exists in Portuguese now, with English and Spanish following soon. So in summary, the use of open source in education allows you to see how the software works. Because when you use closed source proprietary software, you only learn how the software is used to do your job. But when you use open source, you can also see how the software does the job. And you can change the software to make it do the job better. It encourages collaboration amongst the students. and allows the students to use the same software everywhere, at the school, at home, and at the job. When you use proprietary software, you might be able to use it in the school for free or low cost, but then when you move to the job, you have to pay the full license fee, and that could be very, very expensive. It makes sharing of research a lot easier. You can actually share the code instead of just writing a white paper. And it reduces the amount of work for the incremental software that you need. With that, it's the end of my talk. Professor Zufo is giving a talk at 2 o'clock in Sala 4. It's about Canitas Lucas. He'll go into it in much greater depth than I could. And I will show you, for the first time ever, a very sophisticated router system that is being manufactured and distributed here in Brazil for Brazilians. This is the Subutai blockchain router that we contributed this to the Brazilian people. Thank you very much.